All right, guys. So basically, I want to do some of the tough questions that people requested in the Discord channel. So send your questions in the Discord channel and I'll do them. I'm seeing a lot of questions here. So let me just tell them I'm live. Y'all will come through. As soon as you touch down, press like on the stream. Say something in the chat. Let me know that you're there. If you're hearing me properly, let me just see if my audio working. Yeah. So as soon as you're ready to jump out, we're jumping out. Let me know if you're seeing the screen clearly. So most of the questions that people send in, I'm seeing is most of the questions they're sending are the moments questions. It seems like just visualizing the moments question could be a kind of challenge for some people. So let me just look at this question really quickly, and I'll try to rip through the questions quickly because we're just revising because the exam is like tomorrow or some kind of thing. So, they're last minute, they're doing the thing last minute. Identify the nature and point of action of the third force acting on the wheelbarrow. What is the third force? Write it down an equation showing the relationship between the three forces. So what they're basically saying here, that there are three forces. Can I just merge this into lock into the background? Lock into the background. Let me see if I could do it on this end here. There we go. So yeah. So all right, people. So the wheelbarrow is in equilibrium. Don't forget to press like on the stream and share it up and let everybody know. Identify the nature and point of action of the third force. Is there a force on the wheel here that wasn't accounted for? Yeah, man. So there's a force on the wheel here that hasn't been accounted for. Wow, why they make me write like that? They should be active. Thing. What I'm using here is Microsoft Whiteboard. I don't normally use this, but I decided to practice with it on this live. So there's a resultant force acting here. So this is the third force. We can call him F. F2 or resultant force. Whatever you feel we should call here, right? They give us a name for it. They didn't give us a name. I will call him the resultant force. Bang, bang, bang. Resultant force. Yeah. If it's showing and you're not seeing it clear, you need to increase you're gonna let them know now as they come in, you need to increase the thing. So does it matter if it's going up or down? You need to put this force going up. The downward force is the weight. And then what? You need to write down an equation to show the relationship between the three forces. Well, the upward force, so this would be equal to the downward forces. If it's in equilibrium, static equilibrium, downward forces. So what we can expect? We can expect that the applied force, that's labeled F, plus the resultant force on the wheel must be equal to the weight. And then they want us to calculate the weight. Well, to calculate the weight, we're going to use the next. We're going to have seen some comments in the chat that just make it crack up here. We're going to use the next equation. What are the two things that you expect to happen in a system for equilibrium? If a system is in equilibrium, the upward forces equal the downward forces, or the sum of all the forces are equal to 0. Sum of the directional forces equal to 0. And Ronaldo is correct here. Clockwise moments is equal to anti-clockwise moments. So you need to state that. So using the principle of moments for the weight, we're going to activate the principle of moments, and we will have the total clockwise moments equal to the total anti-clockwise moment. And moments is a product of the distance and the force, right? They give us force here, nothing in kilograms, so no suspicious activities going on here. Once again, I'm not too familiar with this. Apparently, I could just be snagging things out of the way there. So it means that W. So I'm going to take moments. I'm taking moments about the wheel. So about the wheel there, I'm going to take the moments right here. I'll zoom out a little bit. Right here. So it'll be 0.6 times W. 0.6 times W should be equal to F by 1.5. Which one is the clockwise? This is the clockwise, right? The W force will be trying to spin it clockwise. Now the fulcrum or the pivot that I'm using is the wheel. So W times 0.6. Now is a good time to change the color. Bang. W times 0.6 must be equal to, who's the next one? F. Applied force. Did they give us the applied force? A wheelbarrow, total mass of 43. Oh, they did give us the W in a smart way here. So what is we trying to find? W. We ain't ready for that yet. We're ready for that. So let me go on the next slide here and look at W. Is the applied force is when we're going to come through this. But let me just finish write it out. W times 0.6 is equal to 1.5, or I could say F. F times 1.5, but they wanted us, so this is what I'll use for part who by part B. For part B, I'll use this for part B. This was part A, and part A. Actually, this was part I. Part I. But for part A, W, we'll simply find W by equal mg. W is mg. So W is equal to the mass here, 43 kilograms, times the acceleration due to gravity. And CXC like to say use 10 when you're dealing with CSEC. When you're in Cape, they will say 9.8. All right, so we put 10, and this is 430 newtons. 430 newtons. So now that was part A, locked. And now we're going to go to part B. And since we know that this is 430, now, we can do a little substitute. Then divide by that 1.5, because we're bringing across this, right? To find the value of F. What you getting for F? What you getting for F? So let me see what the chat's saying. Wait, 43 times 10. Right thing, well done. 43, right. Do one for integrated science, somebody is saying. What's the answer for F? Remember, there's a micro delay. F 172 newtons. And that's it. That's it. Well, at least that's it what the person sent. So the next question that was requested was this question here. Let's zoom out and take in the question. A student conducted an experiment in which 1.5 kilogram of water was at 30 degrees Celsius was converted to steam at 100 degrees Celsius. Assuming no heat loss to the surroundings, calculate the amount of energy needed to heat the water from 30 degrees. So they give you a walk-up. They're walking you through the question. So what method we're going to do here to find this? What law we're going to use to find this? And then you need to convert the water at 100 degrees Celsius to steam and what equation are we going to use to find this? So we have, I don't want to say the topic. Let me see the equation in the chat. So we have 1.5 kilograms of water. They tell us the starting temperature, tell us the temperature it ended at, and everything is steam at the end of this. And I guess there was probably another part of this question they didn't send it. Here in Discord starting to ring off. I need to mute this because then everybody gets started to send a million and one thing and I can make one star noise. All right. E is equal to machine in temperature. What? What is this up here? We get some equations. Huh? All right. EH is equal to MC delta theta. So the energy to heat the water is equal to is a product of the mass and I'm pretty sure down here they had the specific heat capacity in some unit. What unit they had the specific heat capacity in? E is equal to MC multiplied by delta, not delta theta, delta T change in temperature. So that's good. Anybody with this question and they tell you what value they had for C? What they had, 4,200 joules per kilogram per Kelvin, joules per kilogram per Kelvin. See if I can find the question this person sent. Sometimes they pay like 4.2 or sometimes they pay like 42 and they give it in different units and you need to convert. I'm not seeing it. They probably had 4,200 joules per kilogram per Kelvin. That's what they normally have. So let me say, like they gave you that C is equal to 4,200 joule per kilogram per Kelvin. Or they may write it like joule per kilogram per Kelvin. So they say 4,200 will be a constant if they give you, yeah. Don't forget to press like, people. So when we're doing this, it'll be E is equal to M is 1.5. C is the, wait, let me make sure everybody in your writing, 4,200. My boy, not in Kelvin. So to change the Kelvin, what we need to do? So 30 degrees is equal to, what we need to do to change the Kelvin, 30 degrees Celsius is equal to how much Kelvin? That will go there. Ding, 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 at 273, right? So we're going to absolute temperature. So we're going to add 273. So that puts us on 303. So you put the 303 there. 1.5 by 4,200 by 303. Where my calculator? I'm bringing up my calculator on the screen right now. That is easy, man thing. 303 Kelvin. And what you getting? Once I all getting here. And this answer should be in joules because this is in joules per kilogram per Kelvin. This is in kilogram. This is in Kelvin now. Kelvin here. So everybody in the correct unit. So when this fall out on me, this should be falling out in 2 joules. Waiting on the answer. So wait, 30 degrees to, sorry, I have a mistake here. I just put the solid temperature. This is 303. Well, and then it went up to 100 degrees. So this is 403 Kelvin. And that's now 473 Kelvin. My bad, Alia. So the delta T, which is what I'm substituting for here, right? I just substitute the raw thing. Delta T is actually 70. Yeah. So the change in temperature is actually 70 Kelvin. And in this equation, one of the things that we notice is since you have change in temperature, it's not that detrimental if you forget to change from degrees Celsius to Kelvin, because you're subtracting, you're doing a difference, so it doesn't matter. You'll still get the same, you switch whatever. In this case, it was 70 degrees. All right, so is the switch is in 70. 70, put that in the calculator and tell me what you get. And this answer ring a bell. I feel like I do this about 5 times on the channel already. Joules. What did I have? 30. That's 273. Did I have 370? This should be 373. Yeah. Change is 70. What was the problem? That good? Why isn't the chat if that good for you? Why isn't the chat if you everybody understand that? Convert the water, and this is the, we want to find the heat energy. What equation we're going to use for this part here? Convert the water at 100 degrees Celsius to steam at 100 degrees Celsius. We can leave that in joules. Nobody asks me anything. Calculate the amount of energy needed to, they didn't say in joules or kilojoules or anything. You could put it in standard form if you want. Latent heat of vaporization, well done. So H, you're talking about the energy coming from latent heat of vaporization. And this is equal to MLV. There's no delta T here because the change in temperature is just 0. And they would have given you the latent, the constant. They would have given you that for water. What they give you it as? Anybody have this question on them? People sending me questions to do here and they sending me the constant. Is it 2256? Or they give you 2.3 times 10 to the power 6 or 2.25. Whatever they give you, you're going to use that value, right? In joules per kilogram. Let me just assume it was 2.3. I've seen somebody say 2.3. It could be 2.252 by 10 to the power 6 joules per kilogram. And that's going to be your energy there. All right, rate out of 10 how much you understand these kind of questions. I'm going to do our next question requested in the channel. 3450000 joules. 10. Okay, let's do another question. We do the wheelbarrow question already. Why people is always send this bike question by? Every year that bike question has come. Every year. The 2 bike questions has come. Every year. We can expect bike. This question. Have you ever seen this question before? So the first part is just notes. I don't think I need to focus too much on the first part. That's not random. I'll just stick this down. I don't think I need to focus too much on the first part. First part is just a note from your lab. Anybody need help in that first part with the either of label diagram, describe an experiment to determine the center of gravity of the regular shape sheet of cardboard? Somebody could write it out there. Yeah, I'll just see this over and over, right? So this part straight out there, notes straight out there, textbook straight out, whatever your teacher teach, once you have that, you could just go and copy it and memorize it. You must know that some certain experiments in physics, you must know. Right, so let's go on into the bike. Figure 3, no, right. Shows a bicycle of mass 15 kilograms resting in a vertical position with the front and back wheels touching the horizontal ground, P and Q, respectively. PQ is 1 meter. The center of gravity of the bicycle is vertically over O. This is the line of action for the center of gravity. You'll see in there, the center of gravity of the bike is where PO is equal to 30 centimeters, 0.3 meters. Given that the normal reactions of the ground on the front and rear wheels are R1 and R2, right? They call them R1 and R2. That's why I like to call mine R. Amir, where's the word, boy? Kenny and Candy decided to... or write two equations in R1 and R2 which satisfy the conditions for equilibrium. So what equations y'all thinking? We do this already. We just do something like this. What equations y'all thinking? There are a number of equations you could use here. But you should have the equation with the... What equations y'all thinking? Did they give us a value we can use for the line of action of the force? We can call him W. Center of gravity, PO. They didn't really give us anything. They gave us the mass of the bike. Mass of the bike is 15 kilograms. They give us what to use for G. Yeah, G is 10. Somebody say R1 equal to R2. That's a fast way to lose marks, they boy. Fast. You'll be losing marks quickly. They want you to put the equation in terms of R1 and R2. So somebody has R1 plus R2 is equal to W. You all agree with that? So we should be able to write in that. So I can't touch this thing. Right in that this could be a little bigger. That along here is W, where W is equal to mg, and m is 15 kilograms times 10, which is the acceleration due to gravity, 150 newtons, right? So we have W is equal to mg. So an equation, right? The two equations in R1 and R2. What you can put R1 plus R2. This is equal to W. This is the one where the upward forces equal the downward forces. You can write that the upward force equal downward force. This is one of the conditions for equilibrium. And if this comes, if moments comes, for sure, this is going to be one of the things you're going to do. And to be a little more accurate and to secure the bag as 4 marks, I would get rid of the W because they were the equations in terms of R1 and R2. So let me just put what W really is. R1 plus R2 is equal to 150 newtons. And we got W because we worked it out from the before over here, right? I thought this is changed automatically into a square, some kind of thing in this thing. Let me try this again. Nice. So we got W over there. Why isn't it chat if you understand that? Easy man thing? Easy man thing. No, they wanted 2 equations. Another equation would be something with moments, and this is where you could have another. You could have 2 more equations here. Could work out. What are you thinking? What are you thinking, boy? They give us what PO, the length of PQ is. PO is 30 cents, 0.3. PQ is 1. So the whole thing here, that whole thing is 1 meter, right? Whole thing is 1 meter, yeah, the life saving. So since the whole thing is 1 meter, we can get some moments action taking place here. So let me just see if we could like snag up this whole thing. How is do this again now? Yeah. Whatever. Let me see if I could snag him here instead, maybe. Move him up. Remember, this is the first time I'm really using this, so I'm gonna give my chance. Bam, bam. Snag him up, move him up over here. Right. I know what I'm doing. So we want, and Bryden Butcher already have it in the chat device. I was fighting up with it. So we have some of the clockwise moments equal some of the anti-clockwise moments. So total sound like a good word to use. Total or sum, right? So total anti-clockwise moments is equal to the total clockwise moments All of this is for the equilibrium. So the total anti-clockwise moments, we can take moments about P, or we can take moments about Q. They only wanted two equations. So I will take moments about P. So taking moments about P. So I'm going to take moments about P. If I'm taking moments about P, then watch P good. P is over here. So any force on P is neglected because it's zero distance here. So R1 not creating a moment if I'm using P as the fulcrum, the pivot. You understand? So the moment here will be W by 0.3, and this is W trying to turn it clockwise, and R2 is trying to turn it anti-clockwise. So I'll be like, anti-clockwise would be 1 times R2, which I don't know, is equal to what I want to say. 1 by R2 is equal to W by 0.3. And just for kicks, like in the other equation. No, so some people misunderstanding this. Oh, so what I highlighted with Brandon here, some people misunderstanding it. Why isn't it chat if you understand this? If you're taking moments about a point, you don't include the force. Anybody have any questions? So people trying to include the force here. Don't include the force. Kimal got it. And I've seen his comment. Don't include the force. Neglect the force. Neglect the force. This on the point. So this is like R1 times 0. It is nothing. This force is on the pivot that I'm taking moments about P. So I will have like R2 this a little. If I put in W here, I will actually find the value of R. Is somebody sitting on the bike? No. Nobody is sitting on the bike. Okay, just a quick little demonstration of what is happening, because people confuse. If I have, let me see if they'll help me make this plank. If I have a plank, and I have a force here and a force here, let's call this F1 and this F2, and this some distance D1 and D2. Well, then F1 times D1 must be equal to F2 times D2. But if there's an additional force here, exactly on the pivot like F3, you can't include that force. Because forces that act on the pivot, we neglect them. And questions like this come in CXE all the time. There's a question that come with the bridge and a truck on the bridge. Now you want to make shape. I want my thing to look so, we'll make no shape. So, and there's a truck on the bridge. So you'd have to take moments about different pillars. And when you're taking moments about the pillars, the resultant force not included. So another thing that we can see, so 0.3 by W should be equal to 1 by R2. Another thing, if we take in moments about point Q, then 1 times R1 should be equal to W times 0.7. Well, 1 minus 0.3. If it's blurry, you need to just increase the quality of the stream on your end. Up your quality. Go and figure out how to do that in the settings. It's coming across 1080p. So you can send it up to the top. So all of these equations work. And you can remove the W to find out what R is. Kenny and Candy decided to sit. Let me see if I can think about any other equations. This is equal to that and that. Is equilibrium. So you just had those two things. I just redoing any question I'll just send. Because all of this pick out certain topics, them is lie. So Kenny and Candy decided to sit on a seesaw while visiting a local play park. Candy of mass 50 kilograms sat 200. This had nothing to do with the next question. Right, two equations. So R, they asked you to find what R is. They didn't really ask you to find what R is. They didn't really ask you to find what R is. I didn't like this question. It's too sus. Anyhow, Kenny and Candy decided to sit on a seesaw while visiting a local park. Candy of mass 50 kilograms at 250 centimeters from the pivot of the seesaw, where Kenny of mass 60 kilograms, where he should sit so that equilibrium like this. 5 marks for that? That's us too. That's real marks for no work. All right. So let me see. We're going to draw this. Let's draw a little seesaw, because we just put on a little walking thing. Let's make this a thicker line, and we assuming that the seesaw has a pivot in the center, right? What's the length of the? Because they didn't say the length of the seesaw. Well, they want to do some half-lives. All right, well, just send it in the thing. They didn't say the length of the seesaw. So Candy of mass 50, let's put Candy on this side. Candy use that box there. And she has 50 kilograms. So I don't want to put 50 kilograms like that, because that kind of demonstrating that kind of force thing. So Candy's weight is equal to 50 times, and we're using that as 10 as well, right? So this is 500 newtons. So Candy has 500 newtons acting down. This is Candy. And her distance is 2.5 meters or 250 centimeters. So, and we want to put Kenny, who is a little heavier. Kenny is 60. So if he's a little heavier, it's obvious that he would need to sit down a little closer. Kenny, right? Candy. Kenny, like the foot, like the head. All right, so Kenny is some mass here, boy. And we're trying to figure out his mass, and that is what asks we're trying to figure out his distance. Sorry, we have Kenny's mass. He's 60. So I'll do the same. W is equal to 60 times 10. Or I can't see it, but I'm doing it right now on the next side. 600 newtons. So he's 600 newtons acting down. And we actually trying to figure out this distance here. We can call him X, since we like to call thing X when we don't know what it is. And by the principle of moments, you all press like on this stream. Here what? Take a screenshot and post it on your Instagram, because people think like Cohen Spring on a hiatus right now. It's just that going through some real problems. Let me not say problems, challenges. So X by 600 is equal to 2.5 times 500. So X is equal to 2.5 times 500 over 600. This is going to give us in meters. Where should Kenny sit? What do you get there, boy? 2.08 meters. Let me just double check that. It's not the first time them people can lead me down the wrong road if I just take that just so. 2.08 with that 333 thing recurring. Or we can say 25 over 12 meters are the same as approximately 2.08 meters and approximately 208 centimeters from the pivot. Because you have to explain the question. Where should Kenny sit? Kenny should sit 208 centimeters from the pivot on the other side of the pivot. Might be a faster way to say this. 280. Nah, just say from the pivot on the opposite side to Candy. Why is in the chat if you understand that? Every time you do something in physics, watch the question, watch your answer. Watch the question, watch your answer, make sure you answer the question, make sure you answer it in the proper units. Don't be the person to come out of the exam and want to kick yourself. I want to kick yourself because you forget units, or you forget to switch to something and you're just feeling like a big wise people talking about it, right? What should Kenny do if he wanted to elevate Candy? Well, he could don't put this, but he could jump, right? Or he could go up and down like that. And he will get a little momentum and he will bouncy. But the answer that they're really looking for is he can slide backwards away from, and you want to be careful, it's 3 marks, away from the pivot. This will increase his moment, since moment is a product of his weight. So don't be stingy with your answer. If they're not stingy with the mark. So you want to slide backwards away from the pivot and give a little explanation too, because it's 3 marks. Right? So when you see the marks, them fight for your marks in physics. It's physics, yes, but you want to, definitely explain your answers, especially when you just see now 1 mark and that kind of thing. If you have 2 definitions for your Newton law, put your 2 definitions, put your equation thing, your unit thing, secure the bag. This is about securing the bag. You can thank me later. This will increase his moment, since moment is a product of his weight and distance from the pivot. If you're feeling a little extra, you can put any distance more than 208 centimeters away from the pivot will elevate Candy. Or they ask what Kenny should do, but Kenny could tell Candy to come up a little closer now, and you will get the boost instead of me having to slide backwards. All right, enough of that. Let me see what the questions them have inside the chat, inside the thing here for me. Here we have a isotope question. I like how you could copy and paste pretty quickly, and this that's a bonus for this Microsoft Sheets thing. And now we're gonna stick him on there, badang. Now we're gonna zoom up. Clearly label. What is chemistry? Are you really sending me this question, boy? Who sent me that? Cookie, what kind of question is that? Find that question and copy your next thing. I mean, you should be able to draw your lithium and thing if that a chemistry question. Don't know why there's always leave physics for last, and they're always treating physics with that kind of. I tell you, let me do the question. It was sent, we do the question. I just see Half-Life. All right, send all your questions in the Student Hub Discord, right? This is the last question I see, so maybe I can just go after this. Are you good to go? Lithium 7 is an isotope of lithium. The mass number is 7 and the atomic number is 3. Using the information given above to determine the number of protons and the number of neutrons present. So this is a kind of state question. It's just 2 marks. Once you have the correct answer, they're giving you the mark. The mass number is 7, atomic number is 3, so the number of protons is equal to the atomic number. So which is equal to 3. The number of neutrons is equal to the mass number minus the atomic number. What's the symbol for these things, people? I don't know. Let's just do chem. So the mass number is 7 minus 3 is 4. What more you want? Why is in the chat if you understand that? 3 and 4 says NAT or NAT 487 SEEP. Big up yourself. Very clearly labeled diagram. I'm not really interested in drawing this in the hell way. Of the structure of the lithium 7 atom. How much max? 4 max? Damn. Little circles. 4 neutrons, 3 protons. Next little circles. Next little circles. So this nucleus with 4 neutrons and 3 protons. Outside here, we are the bad boys. Them bang, 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 bang. So these are your electron shells. What you really wagging with this, right? I find that 4 max come around lithium 7 atom. Label up your diagram title. How more you want with this, boy? Anything we missing out here? So if you don't draw the circle perfect, will you lose a mark? No. But try and draw a circle looking good now, man. Why isn't it that if you know how to do them thing, that is chemistry, we don't really care about them thing here. You should just know how to do them thing, and I'm not supposed to be teaching that. In 4 days, the activity of a sample of lithium decreases to 1/16 of its original activity. Define the term half-life. So what's the definitions you all know for half-life? There's a book that I have. Let me see if I can bring it up. Physics formula booklet. Edit 2. Stop share that. Share screen. Bang, 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 bang. So there's this formula booklet. I don't know if you could get it. Exam is tomorrow, but if you're watching this and your exam is not tomorrow, definitely get this book. All the students in my class have this book. Yeah, I should label the electrons. And there's the fundamental quantities, the prefix. It's like the ideal thing to study right now. You just go through and you study all your formulae, all your definition, all the unit analysis. I wrote this last month for my students, a month before, and we fine-tune it up. Precision versus accuracy, all the forces, all the blah, 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 all the way down through the entire of physics. Real nice thing. Nice thing. Which is why you need to sign up to the student hub. We treat with students real nice. So everything you need to know inside this book, everything concise that you need to know. You don't have questions per se, but good book. So like you see them definitions, them half-life is half the time take for a sample to decay. Fate. What kind of thing is that? Half-life is the time number of atoms. No. What going on? I tell you, well, I don't like all your max. So half-life is the time taken for the radioactive nuclei to decay to half its value. I could take that. Where am I? Yeah, it's a little bigger. Time taken for radioactive nuclei to decay to half its value. I'm writing it out because I want to pick some other definitions that sounding good. Half-life is a random process by which I don't like that. I don't like this definition, Brandon. Kind of talking a little bit about radioactivity, and then you're talking about the origin. You're talking about the whole mass of the nucleus, which is not true. It's just the radioactive part is decay to half the value. Is the time for half the unstable nuclei is this is it. You see this what is man up here? This is it. Because you could also speak about half-life in terms of the radioactive radioactive activity, radioactive, I can't spell activity, radioactive activity to decay to half its count rate. So half the activity, right? Oh, I should have time taken here. So what he have is really good. Fixed period of time for the activity of the radioactive atoms, and all this is good. Half-life. Watch how much definitions I let teacher give you. Half-life of radioactive nuclei, and every time for the activity to fall to half of its value. All of that is good. Once you talk about, don't talk about the mass of the atom going down to half. Don't talk about the mass of the nucleus. It's the mass of the amount of the radioactive nuclei to decay to half its value. You can follow it up with the next one where you're talking about the activity to drop to half its value, the specific time taken for that. Okay, enough talk on that. They have enough thing there. Time taken for radioactivity or specified isotope to fall to half its original value. The radioactivity. I will take this. I could see myself giving this 2 marks as well. Calculate the half-life of lithium. So they don't expect you to know, for CXC, they don't expect you to know, it is. They don't expect you to know how to solve exponential equations with logs and that kind of thing. So they expect you to use a kind of common sense approach. I'll show you what I mean to solve this. In 4 days, the activity of a sample of lithium decreases to 1/16 of its original activity. So for CSEC, you're not going to do no logs or anything. You're just going to check what are we going to do. In 4 days, it went to 1/16 of its value, right? So let's examine this. And you need to show your thinking. In 4 days, went to 1/16 of original activity. So therefore, if we want to find for one, or if we want to find for a half, sorry, we want to find for a half, the amount of time it will take to drop to half. Oh, sorry, my screen is sharing. Oh, my bad. Are you all seeing me here and thing? I apologize. So look at the chat. Yeah, I don't look at the chat as much as I used to in the past. I just be teaching. I'm gonna focus on the chat. Don't worry, we seeing the screen reflection from the sweat on your forehead. Andy Ram. Come on, man, Andy Ram. So we can see the screen. Thing. Okay. You probably was really seeing the screen reflection. Okay, so where we reach, they said in the question that it went from, in 4 days, it went to 1/16 of the activity. In 4 days, 1/16 of the original activity. How much it will go to take to go in half of the original activity? You could follow our step. You could say maybe, well, in 2 days, if you like to divide this by half, we would expect that it would have been 1/8. Understand? So in 1 day, it will be a quarter. So in half of a day, you get half original. Sorry, 2 days, 4 days, 1/16, 2 days, 1/8, 1 day, a quarter, half day, a half of the original activity. Now, exponents works in a kind of weird way, right? So you see 16, 1/16, and you see 4 days, and you might be tempted to divide 4 by 16, and you might get a kind of whack answer, and you might get quarter of a day or some kind of thing. So some people know equations, but I like to teach this without equations. All these CSEC questions on this can be done without using any exponential equation, any equation on the whole. There's an equation of AO over AN is equal to 2 to the power of n that I learned. It's equal to 2 to the power of n. Yeah, that will work 4 half-lives, but you could normally just count up your half-lives in this for CSEC. Okay, calculate the energy given off by a nuclear reaction if the change in mass is... You all wanted me to do this one too? Here it is. They give you all the quantities here, right? Calculate the energy given off in a nuclear reaction if the change in mass is 0.2014 atomic units. I'm going to use your big equation here, the big boy. E is equal to mc squared. E is equal to mc squared, where m is the change in mass, c is the speed of light squared. We have our mass here is 0.2014 atomic units, and we have what the atomic units represent here. M is change in mass. In this case, it is it is 0.2014 times 1.66 times 10 to the negative 27. And c is equal to the speed of light in a vacuum. So this is equal to 3.0 times 10 to the power of 8. So c squared is 9. Every now and then it stick. 9.0 times 10 to the power of 16, right? Agreed? So you just substitute to go. And we'll have 0.214 times 1.66 times 10 to the negative 27 by 9.0 times 10 to the power of 6. Why isn't it chat if you all get this? 16. Well, where does 6 come out from, bro? Calculate the energy given off in a nuclear reaction. Any change in mass is that. Right. All again. 0.124 times 1.66 times 9 times Did I say 124 or 214? What I say when I was typing just now? 0.214 times 1.66 times 10 to the power of negative 4, 16. Yeah, I'm fighting up with my calculator here. Try this again. Times 1.66 times 10 to the power. Do I have a mistake in here somewhere? So the answer is 3.08. How much decimal places they're looking at, boy? Put like maybe 4 or 5 significant figures based off of how accurate they give this value here now. 0.2014. So 3.08. 3.0089, all of that good, times 10 to the power of negative 11. You all get that? Nice, nice, nice. So 0.20. Yeah, I'd leave all these 0 here. That was a hot end. Okay, so next question. Let me see if anybody else sent something else. Wow, somebody's sending up questions here, boy. Okay, we have this popular question again. Every year the same questions over and over. Every year. That's it? No, I forget the units. Where's this units by change in energy? So that's joules. Joules. Copy image. Why isn't it chatting for a good day? Did I leave out anything else? We have the half-life. We do that up here. Half day. So yeah, I could put out there for half-life. So we could write what the half-life is. Half-life of lithium-7 equal 0.5 over day, or half day, whatever I want to say. 12 hours. I just touching whatever people send me, you know. I just touching whatever people send me. Bang, bang, bang. I copy it already. Let me see. I'll try and copy some work thing and paste some work thing in. This is what somebody sent me. Aaron, one of the big moderators in the student hub, I believe his name is Aaron. Aaron here, Aaron, a Form 5 student, has available to him a bright filament lamp. I'm not describing no experiments and thing. Or another thing that we sent all my students were the experiments. This you could just get it straight from your notes, right? I doing calculations. So interference pattern from notes. Figure 2 shows a narrow beam of white light which is shone onto a triangular prism at the angle of incidence of 30 degrees. Red, violet, if the angle of refraction for the violet light, theta v, is 20. Okay. So this is 20 degrees. What is the refractive index of the prism? Dun, 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 dun. So this is 20 degrees. What is the refractive index of the prism for violet light? So what do you think the refractive index of the prism is? It's something you can just rip out really fast. What would be the refractive index of the prism? How do you find refractive index? Somebody saying 1.46. I'll agree. If it was 1.46, I wouldn't bring it down to the 1.5. I'd say 1.46. Whereas the refractive index have lots of equations, boy, we could use. So which equation you're gonna use here? Refractive index is equal to sin I over sin A. Sin I over sin R. So where I is your angle of incidence, and R is your angle of not reflection but refraction. So this is if the angle of incidence is, this is from A to the medium, not the other way around. There are some questions where it went the other way around, and then you need to sort out yourself to suit. So this is sine of 30 over sine of 20. One of the things that can help is that the refractive index for glass is always about between like 1.3 and 1.6, somewhere between there. So sine of 30 divided by sine of 20. Bang, 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 bang. Did I do this correctly? Sine of 30 divided by sine I over sine. Oh, calculate in radians. So 1.46 sound good? This have no units. The refractive index have no units. 1.46. What topic is this? So that's a good point. Make sure your calculator not in radians. As I said, the refractive index for glass and things is normally be 1.4 somewhere around there. Calculate the speed of the violet light in the prism. What's a way we can calculate the speed of the light in the prism, knowing that the speed of light in air is 3.0 times 10 to the power of 8? What's another way we can work out refractive index, people? Does the light speed up or slow down in the prism? So where should I put the air and where should I put the right? So it slows down. So if it's slow down, it means we want the smaller figure to come here. So we're going to put the speed of the light in the medium here, and the speed of the light in vacuum, or in this case in air, whatever's coming through first, will give us the answer. So the speed of light in medium 1 over the speed of light in medium 2. But I just given you some ways how to think about it. You want to get 1.46, right? Which is what we know. So it means that, and we know the speed of light in air, nothing is going to get faster than that. So you want to put the bigger number here and the smaller number there, right? So working with this little working thing here. Good, I probably can't snap this. Let me see if I can snap this, or if they will snap the picture in the back too. Just checking. You know what they leave me off. But they are snapping the right thing though. They are snapping the right thing. I am impressed. I'm impressed with Microsoft Whiteboard. It's not that bad. It's equal to, remember the refractive index was, I'll use the accurate answer, 1.4619022. That's more accurate. And the speed of light in air was 3.0 times 10 to the power of 8. So the speed, so the speed of, so rip those three. The speed of light in the medium, that was what we're trying to find, right? The speed of the violet light in the medium. Calculate the speed of violet light in the prism, right? So the speed of light in medium, violet one. So the speed of violet light. Why writing this so much time? And I could get a shortcut for this one. Violet light in medium. We expect this to be 3.0 times 10 to the power of 8 divided by the number. What you get? Times 10 to the power of 8 divided by 1.46190022. This is equal to 2.05 by 10 to the power of what? 8? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 2.05 by 10 to the power of 8 meters per second. Let me just double check with units. Everything looking good. 1 nanometer is equal to what are they getting me this for? Oh, they're going to give you some frequency talk. So life is short. This man asking the real questions. Oh, this woman asking the real questions. Can someone give me the list of things I should know? Everything. All right, let's keep going. Calculate the frequency of violet light if the wavelength in air is 430 nanometers. Okay, so we have the frequency in hertz. What's the wave equation? What's the equation that links frequency, speed, and frequency, speed, and wavelength? V is equal to F lambda, right? So V is equal to F lambda. Or if I just write your lambda. So the velocity is 3.0 times 10 to the power of 8. The frequency is what we're trying to find. And the wavelength is 430 nanometers. So times 10 to the power, we need to put that. So velocity is equal to frequency times wavelength, F lambda. Somebody put F ladina. Now, Venja normally is get everything correct. What going on there, bro? Change. So what next? What next in the dance, boy? Zoom in a little bit there, father. Thank you. So we're going to divide. So this will give us the frequency in hertz. Every now and then, my thing cutting off. There's a problem with this though. It disconnecting a little bit. So you get the 3.0 times 10 to the power of 8 divided by 430 times 10 to the negative 9. Just how much? What's the frequency of normal violet light, boy? That making sense? This making any sense at all, yeah, boy? So 6.98 times 10 to the power of 14 hertz. 6.98 by 10 to the power of 14 hertz. 6.977 will be a little more accurate. What kind of thing they use in here? They use 3 significant figures, so 6.98 is good stuff. Very nice, Mr. Springer, says the Ministry of Education. Put some capitals on the Mr. and the Springer, please. Thank you. We want everyone back in physical classes by September. Ministry of Education, you put capital letters on, what you call them thing? Nouns. And these nouns, September. What you call them kind of nouns? I don't teach English, eh? Let's call them nouns. I need to put the capital letter on September and thing need a little thing. All right. Hey, doubles tomorrow. Trinidad borders opening back up tomorrow. Anyhow, we not time to talk about that. Let's see what a question them have inside here for you. Whoa, the question's starting to pile in now, boy. I cannot believe this is a question. I'll answer this question for this person. Peace. Wow, that was tiny. I know what happened and I'm copying the actual photo itself. So just fill in the blanks for this person. Otherwise, I get the next question. Fill in the blanks there. Proper nouns, yeah, proper nouns. So a word is a word. Proper nouns. I don't know anything. I do good in English. Yeah, let's see Aaron comment. I can't post it up here. I not on that. I didn't see no answers for this. Ministry of National Security want a negative. Yeah, that's too much people inside there. 500 people inside there. We need some negative PCR test, please. Lens is not coming. Don't revise. I don't revise lens because lens is not coming. If I were you, I would still touch on lens a little bit. Don't just leave it completely blank because we don't trust these people out here. So just a little touch ain't gonna kill nobody. A little touch ain't gonna zoom up a little more. Complete the following statement. Yeah, it's a little fuzzy. This one fuzzy. You know they gave a list of topics that's coming. We have that list of topics, boy. I did it in my class so many times, but we didn't do physics since like last month our classes finished. The principal focus of a concave lens is defined as the something on the principal axis from which rays originally. So there's the point on the principal axis from which rays originally something to the principal parallel to the point parallel axis after passing through the lens will emerge or converge. Parallel converge, yeah. Converge. So point parallel converge. Point parallel. So point parallel converge. There was parallel coming, they converge down. That's the principal focus. Next question. I'll try to copy the more higher quality image. Paste. Define the term radioactivity is the question. So what is the definition for radioactivity? Diverge is a concave or convex lens. Let me just check that over. Concave. My bad. I didn't read this good, people. Thank you. Saving the nation here, boy. I'll read all your questions carefully. Don't do like me. So just getting rid of this converge is diverge. Why only hear noises for, boy? Is me alone inside here? I think. Well, yeah. If I can come back, call the police. Haley, call the police. Yeah, but I'm writing this in the wrong spot because I just changed it now and it switch off. So is that is colorful pen thing here. I wonder how that work. The point I find it freezing up now. The point dosary would never freeze up like this, so you better find that yourself. So maybe I need to go on a new one. I'm going to open a new whiteboard to see if maybe that's why it's freezing up. Let's give me a second there. This thing will take long. Boom. Bang. We there? This. Make it a little bigger. Nothing to talk about. Just a nice thing. Define the term radioactivity. So radioactivity is the process by which an unstable atom nucleus loses energy by radiation. Yeah, 2 marks. Yeah. Radioactivity is the emission of ionizing radiation or particles caused by the spontaneous disintegration of atomic. Yeah, spontaneous disintegration of radioactive sample with the emission of alpha, beta, and gamma rays. Faith, you come back good there. Your first definition had it really, and this stream was kind of bootleg, but this one touching, this one good. Radioactive decay is the process by which an unstable atomic loses energy by radiation. All of these we taking, but you see it's 2 marks now. You're gonna be complete. Talk about what you know. Just don't talk stupidness so them can take away your marks. Complete the table below to show the properties of the tree. Oh yeah, I think it had a little contention in this. What is the charge? So give me this column here, then give me this column here, then give me this column here, then give me this column. So we're doing this column first. So what's the charge on alpha, beta, and gamma? Alpha, beta, gamma. What's the charge? There's a tiny delay. So in the meanwhile, I could probably put up the answer to these others. Charge on alpha, somebody is saying the charge on alpha is 1 plus. Charge on alpha is 2 plus, right? Then charge on beta, negative or -1 or +2, however you want to write it. One negative charge, and the charge on this is negligible. We could get away with 0. Not really doing anybody anything. What about the ionizing ability? Ionizing ability of alpha, beta, and gamma. I don't know why these papers is. People just sending me papers. Ionizing ability of alpha, beta, gamma. You can write the answers for this too one time because that was slight delay now. We have to speed. Highly ionizing, we can take that. Moderate and low. Low to non-existent. Strong, weak, fairly weak. Strong. I wouldn't call this particularly weak ionizing ability, but it is, yeah, I think moderate in this case would be the better word. And weak. Range in air, few centimeters is good. Meter is good. And very far with gamma. They could write the answers for this one right one time. Oh, I think they wanted to actually draw the appearance. Now, this is interesting. This one is interesting. I'm going to see what they're going to do. So, few centimeters, so 5 centimeters, a few meters. So, example like 5 centimeters, example like 5 meters. And I don't know what to write for the gamma. Range in air is electromagnetic radiation. The range in air is long, very long. Well, anything else could travel better in air than that? A long distance. Appearance in tracks. So I all know about the appearance of alpha, the appearance of beta, the appearance of gamma. And I probably need to bring up my diagram on this. Do I have a diagram set for this? Now, gamma has an interesting pattern because where is it? Because of an effect that happens. I'm a diagram for this way. This coming by. If any of my students here, can just send me the diagram I send a for this. I can't find it with what I have right now. Jib. It is in a cloud chamber. The other thing they could ask is how it would look in a magnetic field. Maybe it's in the notes. So alpha is short, thick, straight. Beta is thin, irregular. Gamma is very short, very thin, very irregular. CXC spine, know the thing. Short, thick tracks due to high ionization. Strong in ionizing on the collision. Tack straight and broad. Twisted and less prominent, and short and broken. That will work. So the tracks in the alpha, we normally get these kind of and to give you all the actual diagram. There we have it. Copy image. There we have it over here. So alpha thick and straight with occasional deflection if the alpha particle collides with the air molecule. Bless up. Somebody send it to me too. Beta particles, here we go. Thin and crooked, the particles cause much, and it will dim out after a while. And then these don't really produce any tracks. So what really happening, what we're really seeing here is an effect that happens when the gamma radiation, the photon, the tracks seen are caused by electrons which have absorbed energy from photons and have escaped. So these tracks is not really in the gamma ray itself, is electrons taking in energy from the gamma radiation and pelting out. Like, yo, energy boy, and they fly out. And that's what we're really seeing. So these tracks not really attributed to the gamma ray itself. Understand what I'm saying? All right, enough talking there. Oh yeah, they give it in the magnetic field too. So how we'd expect the tree to go in the magnetic field? This is going into the paper. This is going into the paper. Into paper. It means the field is going into the paper, right? The direction of the magnetic field. Must know this. I have a diagram for that too earlier. I have a diagram for that. But you could just memorize that and brace it in tomorrow. My diagram. Ting 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 ting. Write the answer in the meanwhile. I don't have the diagram into the field. I had to copy this one. I don't have it into the field. I have it out of the field and I have it with the two plates. All right. Let's talk about free fire. Write the answer. So the alpha goes to the left, gamma goes straight, beta goes to the right. But this is if the magnetic, this is if it going into the field. Field, current, movement, alpha. All right. So you're using your Fleming's. Just now, eh? Field, current, movement. You're using your Fleming's left. Using your Fleming's left-hand rule. Using your Fleming's left-hand rule for this. This finger is field. This one will be the direction of the. You're setting up. Remember this. You can use this to help you figure this out in the exam. Because what if they decide in the exam to have it coming out? This one is going. If they just put dots, I mean, like it coming out of the paper, it will go the opposite way. I mean, you can memorize for both ways. But yeah, you want to use the left hand rule, not the right hand. You're using the left hand. So you're going in, the field going in, the current going this way, and because current will go in the direction of the positive charge. It's traditional, it's conventional current. You understand what I'm saying? So you shoot it out this way, the current is going this way. I don't know, y'all seeing what I'm saying? Why is in the chat if you're understanding what I'm saying? The current going this way, so that's where the middle finger pointing, the field pointing into the paper, and your thumb will indicate the direction of the movement. So this guy is going to move so. He's going to move so. Notice he doesn't move, he doesn't get as deflected as easy as the beta. Alpha versus beta, right? Alpha, gamma, he unaffected. And the beta will get deflected more, but to the opposite direction, because technically the beta, the current is going, the conventional, already is an electron running here, and the current really running this way. Conventionally, the flow of current would be like going opposite the movement of this charge. So if you're using Fleming's left-hand rule, you're pointing this way, and therefore you expect the movement to go to the right. Or you can just memorize it. Yeah, you know what the answer is? Yeah, I'm gonna memorize this and done. You could just memorize this and done. But remember, if you're going into the paper, like if it was into the paper instead, dots, out of the paper instead, you would expect the mirror image of what you're seeing there to happen, right? The beta will go this way. Why is in the chat if you understand that part though? And with that, you're good too. All right. But I was kind of anti-memorization in physics when I was younger, so memorize nothing. Magnetic field is replaced by an electric field. You're expecting a similar situation, but you'll have positive and negative charges to guide you. So what y'all think? Draw the three ways to represent the part of each. So you have two plates. The left-hand rule is used to Fleming's left-hand rule is used to figure out the motion. It's like a motor effect. So yes, we use it in electromagnetism, but we can use it to figure out how these particles will deflect the movement that will be inflicted on them, in other words. I'm really wild in this chat, right? Oh my God. Yes, so the beta, remember the beta is a fast moving electron, right? So the beta, we expect the beta to just fly to the left. The beta left, gamma nothing. Gamma, once again, gamma unaffected, although mind doing a kind of waggy-daggy thing. The beta, we expect it to be very quickly attracted there as compared to the alpha, which you take he attracted there too. Hold up. Who would be more strongly attracted? Would it be the beta or would it be the alpha? What should I put here, man? Zoop, 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 zoop. Now, we know the alpha will go to the right side and we know the beta will go to the left side, but who will be more strongly attracted? The electrons are lighter, but the beta has 2+. This is interesting. Anyhow, it's usually the alpha line. The alpha is normally do this. I'll can double check that one for me. The alpha has a 2+. This has but the beta lighter is electrons. So my money on the beta. My money on the beta. Let me double check. Ding 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 ding. Yeah, that beta going and feel it. Beta going and feel it day faster. Beta lighter. Although it's just one electron, that electron will feel it faster. Yeah, it's the beta. I'll can double check that beta. And my money on the beta. The beta, he will experience a stronger turn. It's just one electron. He have the momentum. Yeah, so the beta will turn faster. You're catching now, you're feeling that. That's what I'm feeling. My physics teacher didn't even cover this self-fill bird too. Well, yeah, it could come. Okay, next question. Hey, you could hold that whole thing and move it. Very interesting. Betting 4 doubles and beta. if this man willing to bet 4 doubles, well, then it had to be beta. Although the alpha has a 2+, the alpha heavier now, so the momentum, it wouldn't get dragged into this as fast. That's my logic for that. Next question. What it is people asking here? Describe with the aid of a diagram how pressure in liquid varies with the depth of the liquid. That's a lab. All you want to do that one? Really feeling that one. I didn't come here to do notes, and I come here to do questions. Ting 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 ting. Describe with the aid of a diagram how the pressure in a liquid. Go ahead. What next? Carl and his friend. Oh yeah, I like this question. Thing I could read off in all your notes. One of the things I told myself back in school and up straight up to university, and I was like, anytime them give me to memorize something, I get full marks. You mean I just need to memorize something and repeat it back in the note, repeat it back in the exam? Anything to memorize, I get full marks on. I memorize every single lab, every single note. Where it is to memorize that is nothing. The only place I could, I tell myself the only place I could find myself losing marks and be satisfied if I lose any marks is in a calculation if I make a mistake. But if it's to memorize something, if I get it wrong, it's because I didn't memorize it. And what it is to memorize something, nothing. As soon as you figure out how to memorize, you're good to go. At least that's what I used to tell myself. Oh, the quarrel over whether I'd come in or not. Just regurgitate the info I saw, just memorize it, draw the diagram a few times, make sure you have it down, and memorize. It is to memorize it, nothing. If you find again struggle to memorize things, you need to work. You need to work on that and how you study. As pressure increases, depth of the liquid increases. Yeah, if you're right and you get the marks, you need to go in deep. Supposedly not coming, so they're not learning this. All right. What you would do in this, you put the diagram. This is the lab with the one thing, boy. This is the lab with the I will never remember this lab with the is it with the hole. So you have the same thing and you open out a hole here, and no, this one will drop here. When you open out the hole here, this one will shoot out further, and you can measure the distance. Right? And that's because the water here experiences a greater force than the water here. And then in your explanation here, you want to say something with pressure H rho G. So is a product of, you all remember this lab, or I just making up things here, or I just did not study this? Pressure is as a product of the height or depth in the liquid multiplied by the density multiplied by the acceleration due to gravitational field strength here. So if you increase any one of these things, if the density goes up, pressure would increase. If the gravity goes up, it would increase. If the depth goes up, it will increase. The water at the top here is only experiencing a downward force on its area with the from the water molecules above this particular line. And since there are less water molecules above this line, less. Just forget this and do the calculation question. Or they didn't do this lab. Anyhow, since there are less water molecules above in the height above this hole here, it wouldn't experience as much a force. This might just trickle out. My line must be generous. This might just be drizzling out like this. Understand? But if it is, how you select things in this way? I just select something and end up selecting the whole thing. Like how is pinpoint? I had to practice that part. This one has a high amount of pressure because it's experiencing a greater force from the molecules above it. And density and gravitational constant is causing that force. Okay, enough talk on that. Carl and his friend Tommy. You could show 3 holes. Yeah, you could show 3 holes. Carl and his friend Tommy. Well, yeah, you could just use one container and show 3 holes. Carl and his friend Tommy were doing, you know how much time I say Carl and his friend Tommy? We're doing an SBA. SBA for you, boy. And the estimated speed of sound using echo method. Okay. Carl stands 100 meters. Well, how are you looking like he in front of Tommy? So Carl claps 2 wooden blocks to produce a series of echoes, and Tommy, who is standing beside him, starts his stopwatch. Big yawn. After one, well, the speed of sound is about 330 meters per second. So you know you want to get that answer, right? So when if they give you this in the exam, you're looking for about 300. Rajveer send a link with the diagram. We send that in this chat. You see no link? Or they block it? They block it from posting the link or? They must block it from posting the link. I could only take off that block on YouTube, and I don't have YouTube open up. Yeah, so the link is showing up here, so the link probably blocked. Or one of the moderators could maybe, I don't know. I'd make a lot of people moderators here, they could probably sort you out there. So after one echo, Tommy stops the watch. This process is repeated. At the time for 50 echoes is calculated to be 30. So what are you doing? Backs, he hit it. Right, he start. Echo. 1, 2. Calculate the speed of sound generated. So the time taken for 50 echoes. So we now assuming no trick. So it's not like no 49 echoes. We ain't taking off. They say this is the time taken for 50 echoes. So 50 echoes take 30.3. Now for echo to happen, you have to go hit the wall and come back. Clack. Clack. Every time you hear the echo, you're hitting it. That's what you're doing, right? To produce a series of echoes. Well, that's what he's doing this lab. Every time you hear the echo, you hit it again. This is like you clapping with the echo until you get a nice little system, and then you start timing, and then you go. So it had to be 100 times 50 times 2 because you had to go hit the wall and come back. So the distance travel for those 50 echoes. Well, where am I thinking by? Okay, here it is. So the speed of sound in this case will be the distance travel, and I'll use distance travel instead of displacement, otherwise I'll end up going 100, take away 100, I'll end up with like a 0. So I'll use distance travel over time taken, and the distance travel will be it's 50 echoes. I'm doing 450 echoes earlier. Distance travel will be 50 times 2 times 100, and that took a time of 30.3. Once I'll again with that. Once I'll again that way. 50 echoes, 30.3 seconds. Everything in the right unit, 100. Yeah, boys, what again with this? 100 times 100 divided by 30.3. 30.3. So you get 330 meters per second to the nearest second. All right, cool. Somebody said 200. No, it's 100 times, or 200 times 50 divided by thing. Okay, cool. Okay, next question. Somebody send me some kind of thing. I forget what it is. Vinay, is that a virus? Vinay, where you sending any people here? In the Discord channel, bro. Copy image. Y'all, at every exam, people is send wrong thing saying it's the exam, and it just be either a virus or some kind of stupidness. Oh shucks. Yeah, all you can do this. So explain where you get the 2 from, because it going and hit the wall and come back is twice the distance. I explain where you get the 2 from. It going and hit the wall now. It travel twice. Anytime you get these echo questions, you have to make sure maybe you travel the whole distance now. I never do this question. In this comment, if the density of liquid X is that, calculate the pressure in pascals due to the liquid column AB, which is 8 centimeters long. This have a next part 8. This man leave out the critical part of this question. I don't know. I the 1 mark part. What the next part? Why people only send me pressure question? Pressure questions gain only pressure. This really easy though. This is H rho G, right? Density by height. Make sure your height in meters. Change it to meters. And G is 10. So I'm not going to do this. I'm not going to do this. Your Alex. Who sent me that? A piston traps a mass of gas in a cylinder at 25 degrees Celsius. The pressure of the gas is 5 atmospheres when its volume is 50 million. Well, I read that whole thing. I ain't see nothing anyhow. Let me just go and calculate the volume of the gas if its pressure drops to 1 atmosphere at constant temperature. Who law is this? Every single time I teach this, I had a recap who law is who and all kind of thing. So it have Boyle's law, Charles' law, and the pressure law. In the pressure law, pressure is not constant. So in Charles' law, pressure is constant. You just touch this again. They say any of these things come in, Boyle's law, gas law. So you have Boyle's. I write in here, but nothing coming out. All right, enough there. I'll go down a little more. So I have Boyle's, Charles. They specify that a law coming. They specify a certain law coming, Charles, and pressure. So why is do I say who constant? Why is B constant? Well, obviously, the amount of the mass of gas used is constant, right? The mass of the gas used is constant. But what is held constant in the pressure law? Not pressure. Pressure is the responding variable. It's the thing now we watch and change. Also, so in Charles' law, pressure is constant. Boil, that going to temperature. So I'm going to just go out on a limb here and say boiling and temperature. That's constant. And in the pressure law, who are the volume? Volume is constant. Somebody say there are 4 gas laws. Well, yeah, then there's the entire thing. We come to that. So the Boyle's law, we have this is the only one where you get this kind of arrangement. In the pressure law, so you get this inverse arrangement now. It's a direct proportionality, and this one is direct. The pressure is constant, so we get per volume now. And in this one, pressure is proportional to, why did I put K? Should I put T? Pressure is proportional to the temperature. Why isn't it that if you agree with everything, me? So if we had to get rid of all them proportional signs, what we gotta do, boy? If we had to get rid of all them proportional signs, we gotta put like a K or some kind of thing. K over V. V is equal to KT. Not all these K's is not the same K, just for whatever gas, whatever condition there. And if we need to combine everybody, we'll have something like what we gonna have if we had to combine everybody? What we could put? What is equal to a constant? Pressure by volume is equal to a constant PV over T. PV over T equals a constant. That's great. But a little more useful than this. Is we can, and there's a nice way to examine it. And it's in the book that I tell you about. We could put like P1, V1, T1, and I've seen some people in chat of it. is P2, V2, T2. This is what you'll use in the question. So a lot of people just take this and go with that and forget about these guys because you could just hold one of them constant and get the other equation. So P1 times V1 over T1 is equal to P2 times V2 over T2. So this just speaks about the same number of molecules of gas in different stages of the experiment, different times of the experiment. So you could just memorize this, but you should still know each one of them individually. And you see how I work it out, right? I don't have it memorized. I try to memorize as least as possible in physics. Ace, this is Samantha. This is Samantha who has a lot of stuff on physics. Let me just double check on my YouTube. If it's so, I could go and go and check her channel after I leave. Where am I? If it's so, I could go and zip. Samantha's positive moments. I'll just give me a second there. This could be Samantha's positive moments. Videos. Nah, they not. Sorry. Wrong Samantha. This is not the Samantha. Unless, I don't know, she deleted all her videos. It's not the Samantha. Okay, cool. So, vibes. What are we doing? What are we really doing out here? Right, we're doing this question. Take a little while to get to this question. Sorry for the delay. Calculate the volume of... But I think there's a Samantha who does physics and she has some physics stuff up. Calculate the volume of the gas. You know what? Since I spent the time looking for it, let me just get her channel one time. I'll post it here. Samantha Physics CSEC. I think it's Samantha. What's her name? Yes, Samantha Blundell. Does she do stuff still? Yeah. She had a chemistry, a whole... Hey, Samantha channel is on fire. She had a whole 30 days. Gravity, weight, motion, kinematics. Let me just bring it up in the screen and show you what I mean. So I could go on vibes this afternoon. I'm going and I'll go on a channel. Yeah, well, just pause what you're doing right now. Go on the channel, subscribe, go on a video and tell her, cool, send you. And then come back. I give you another 2 minutes. So she a real thing. She have chemistry, moles, intro to physics, light, electric. I know you're gonna enjoy this. She's one of them PowerPoint teachers. I don't deal up in PowerPoints and them kind of thing. I just teach. Right? So you could go and vibes that. Look, she have CXC style multiple choice. Miss just shelling here. And one night she looking for a job in the student hub. No, this is good. This is good stuff. This is good stuff. Watch how much. I could go through. And I know back in the day she used to do handwritten stuff. So she upgrade. Listen, good thing. I spoil you onto good thing. 2 more minutes to go and subscribe. Her name is Samantha Blundell. Samantha Blundell. Let me just put the link here. And see somebody say our videos are boss. Yeah, I know I'm a good teacher too. I mean, I know I'm a good teacher too. But she has some good stuff. And I listen to 1 or 2 of her videos, and some people may like that style of teaching as well. My style of teaching more board oriented, talking, question, joking, that kind of thing. But if you want that kind of PowerPoint vibe, and Miss does good stuff. She has past paper videos and things. All right, time up. Time is up. Just tell her coincidentally. Well, it should be filing back into class right now. Refresh the page. Let me see how much you get. You really want me waste time to refresh page and think to see how much you get? How much you had before? physics, CSEC, Wandel. And then I close off my own live stream trying to do this. She get subscribers. I didn't see how much she had before. Well, they subscribe. Everybody subscribe. 2.38. I don't know how much it was before. I don't know. She get extra 300 at least. Big up. Blessings to she. Oh, 2.4K. It did raising. Are they really subscribe? Well done. All these good people, boy. Good people. Share. I mean, it's the day before exam. What you have to lose? What do you have to lose? Somebody only asking for motors. Let me see. Somebody send a motors question here, right? No. We do not question first. After this question, we do the motor. So calculate the volume. She had 2.1, so she got 300. Well done. Calculate the volume of the gas if its pressure drops to 1 atmosphere at a constant temperature. So you can use the P1 V1 thing. Let's see if we could activate the sharing gun here. P1 V1 over T1 must be equal to P2 V2 over T2. I thought the division line thing there was my thing, yes. Zoop. Zap. And what are we trying to do? I just jump into this real fast here. Normally, to make it look a little more logical, we put the P2 before the P1. I just using the big equation. We put the P2 before the P1, so like we get the final. Let me see. I didn't look at the question yet earlier. So like that. Understand? So you might just start off like that off the bat. And yeah, you could use Boyle's law and ignore that. But what is constant? Calculate the volume at 25 degrees, the volume pressure. So, okay. So temperature. What is L constant? Temperature is constant. So we could ignore this. You understand? We could ignore that and we could ignore that. It held constant. Why isn't it chat follow with me? And then you have P2 V2 is equal to P1 V1. So the pressure of the gas is 5 atmospheres when its volume is so that's the initial. So let's say P1 is 5 atmospheres. And the V1 is 50 milliliters. And we can leave it in milliliters. We are just calculating the volume in milliliters. They didn't ask for it in any other thing. So it's okay to keep it in milliliters. We don't need to bring it to the standard units. We could always change 1000 cm cube is equal to 1 liter. We could always change up. Calculate the volume of the gas if it's thing and if it's so P2 is 1. All right, so everybody with me? P2 is 1. So this went to 1. V2 is what we're trying to find. T2, we could ignore that. That's held constant. And P1 is 5. You understand now? Substituting. And V1 is 50. What's the answer? Anybody? I put the answer from before. 250 milliliters, yes. So the answer for V2 will be 250 milliliters. 4 marks for this. What in the suspense? Sometimes physics is be real weird, boy, and maths is the next one too. These must be distributing marks real crazy. So I would be real careful with this. So I would like to say this is Boyle's law. You know, I write it down everything I know here though. So you get your answer, but you want to make sure that if there was any points that I need to think that you have it down. They just be giving away marks. There's like a couple videos on me on YouTube, more than a couple with me doing entire physics papers on YouTube. You see when I go into the paper and I watch the marks, I be real suspicious and go back and neaten up the question a little bit. Anyhow, that's it. So yeah, this is Boyle's law, and you can state a little more about Boyle's law. And temperature is constant. This is Boyle's law. 1 V2 ting 250 ml. If you want, you could convert this to cm cube. Using the conversion, 1000 cm cube is equal to 1 liter, 1 dm cube. Tell logic gate it can see. All right, let's do the next question. Right, so we have this question here. This question have a massive trick in it. Is this the one with the trick? I don't think this is the one with the trick, but there's one of these questions that come with a trick. I did it in my class already. Lock, line, and sinker. With reference to the DC motor shown in explain how the coil is able to rotate continuous. This is our next thing to just memorize. Like I gave you all the entire note on this. Let me see if I have it in my book. I'll just pull it up. Do I have it as no? I don't think I have it in. I have it in the notes. Through here from a class, boy. If you're from a physics class, just say hello there. Let me see if you're here. In physics class, like the bus out. Like we do this already. Okay, let me talk about it. This is a DC motor, and you need to explain how it's rotating continuously. So you need to be able to explain your split ring commutator to the T. The motor effect is a left hand rule. So remember we talked about the left hand rule. So you're gonna use that a little bit to explain. You can even draw in your diagram to help you out, or draw the left hand rule to help you out. Rate out of 10 how good you all are in this. I don't want to waste no time on this because I've seen people talking. Rate out of 10 how good you all are in this, like in collecting this 6 marks. People want me to send the notes for the student. There's notes that people pay for. I try to give you everything, but certain things that are some kind of morals and discipline. Haley here. And that's the Haley. Why are seeing so low scores? That is 0 out of 10 you are in this. There was this really nice video that I found on YouTube. Let's see if I could find it back. It's a whole class. Where is it? Yeah, this is it. But you need to practice putting it in words. Go mark this down. Store this. I'm giving you something to follow. And this channel has really good stuff too. I don't give you fish. I teach you how to fish. So this channel Cognito, explaining everything in 4 minutes videos, 5 minutes videos. That anybody ever see this channel before? So they're going through the motor effect. Then they will go. So they talk about the motor effect in this. How to use Fleming's left hand rule. Then bang, they will go into how the electric motor work. It's a long explanation, right? I'm not here to do the explanation part things and doing the question style. And you can just continue. You can just continue with it. To have it in like a whole playlist here. Right? Cognito. Good thing. Playlist, physics, 88. Just watch the whole thing. All right. So I'll just give it in a nutshell. What is happening? What's happening in a nutshell is that something called the motor effect is being created, because when you have an electrical current or electrical charge carrying conductor in a magnetic field, it experiences motion depending on how it is positioned, and it follows the pattern with the Fleming's left hand rule. So as the current, and when you're explaining this for CXE, take no word on this. This is what we normally do. This is what we have been trained to do. You come and label your diagram, or you could even draw this like this over here, and you label your parts A, B, C, D, like that. That's very important for your explanation. So this segment, when the current is going like this, and you can even draw, what we used to do is draw like two situations. Or three situations. This is A, B, C, D. I don't know if it will turn this way or that way. I didn't check to see it. Let me see. So Fleming's left-hand rule, current, field is always from north to south, right? Leave the north, enter the south. The field is how a north pole would move. A north pole wouldn't want to go to the north pole. It will leave the north and enter the south. The current going that way, and the movement is actually, which way it's going to move? Which way AB going to move? Will it move down like clockwise, or will it move, anti-clockwise, or will it move up clockwise? It will move down. It will move anti-clockwise. So the field anti-clockwise. So AB, this is the line, this is the part you will mention on, you'll talk on. And CD, the current is going this way, the field is that way, so C will move up. This will move down, and it will create a clockwise, anti-clockwise rotation, couple. So you use Fleming's left-hand rule, and you get that going. So soon AB will end up here. This is the next part where you're collecting the next part of the marks, right? AB will end up there. And I'll take my word for it and use these little diagrams, just these little diagrams to help you explain what you're doing. You want to secure the bag is 6 marks. When you're giving you 6 marks, you want a little diagram, you want to pour out your heart and soul and make sure you explain your thing properly. If I were you, I would practice this now. Like just take 20 minutes after I stop and make sure you can do this, and the next one, the generator one, right? Or whatever they say coming. Whatever you feeling like you want to take your chances on. But make sure you have it done, practice, and prep for tomorrow. Yeah, when it reaching this situation, what will carry it over is the momentum. Because when it's at this angle here, it's not really cutting the magnetic flux as it should. The both of them. So it's the momentum is going to carry it over. And this is where the split ring will come into play. As it flips over, the current will still, so this is position 1, this is position 2, and you can mention it like this. It come back here. No, because it's rotating, right? What here now? C and D. A and B is over here because it rotates. You all with me? Why isn't it chat if you understanding what I'm saying? It rotates, it come down, and then B come up here now. But the split rings will allow the current to continue moving in the direction that will allow continuous motion. Because the split ring break the circuit. Hey, all you not see that part I was drawing there, boy. All you can press Y in the chat and all you not see nothing. Right. Things say we not see in question. The split ring will break the circuit, and the momentum will allow it to carry over. Okay, that's enough talk on that. Go and revise that, watch the videos I tell you to watch. Then you go into the calculations. This has nothing to do with the previous thing. Calculate the period and frequency of the alternating supply. All right, how are you calculating period? This here giving us time, this here giving us current. Sometimes you see all kind of thing in these. This is a circuit. This is alternating circuit waveform. Waveform shown in figure 4 depicts the current through a resistor in an AC circuit. So the period is the time for one complete oscillation. And if you look carefully, one complete oscillation would take 30 seconds. So the period is equal to the time for one complete oscillation. If you're seeing it blurry, you just need to change the settings in your side of things. The time for one complete oscillation, period is the time for one complete oscillation. Calculate the period and frequency, 30 time in milliseconds. Nice. So it's going to be 30 milliseconds. 30 milliseconds. Did I say seconds just now? If the resistor is 45 ohms, determine the peak-to-peak voltage across the resistor. So how is get peak-to-peak voltage across a resistor? What's the formula? Now we have the current, but this is not the okay. This is the current. We have the resistor, and you want the peak-to-peak voltage. All right, so there's something called RMS, root mean squared, root mean squared, RMS. That's not what we want. What we want the peak voltage. So the peak current is 4. This is in amps, 4 amps. How are we going to get the peak voltage? V is equal to IR. The resistor is 45 ohms. This is the resistance. This is the current. V is equal to I squared R. And calculate the maximum power dissipated. That's now. Peak to peak RMS voltage, peak to peak voltage. RMS is the root mean squared. Okay, let me go with the grace of God here. So, okay, peak to peak voltage. We want our peak to peak voltage. The RMS voltage is where you use the root 2 thing. You want the peak to peak voltage. So the voltage here, if we need to convert this to voltage at peak, what you get by is equal to IR is equal to 4 times 45, which is equal to how much I get? 180. So this transfers over to, if we have this circuit again, this will transfer over to 180. Is this the answer? Is this the answer though? So at here, we can expect 180 volts. But peak to peak voltage, you have the RMS voltage and you have the peak to peak voltage. Peak to peak voltage talks about the difference between like here, like the actual travel. So you have to multiply by 2. Excellent. So the fact that this is 180 going this way and this is negative 180 going this way, the peak to peak voltage, therefore the peak to peak, I could put this way. You understand that? So the peak to peak voltage is like the whole thing. But you understand the peak to peak, therefore peak to peak, fit in there? Peak to peak is equal to 2 times 180 is equal to 360 volts. So yeah, that should be good. Peak to peak. First CSEC, they're giving you all RMS, right? Root 2. I don't teach my class that, but on the or 8 times 45, yes, that'll work as well. Yeah, so if that's for just the voltage at the peak, yeah, you put 180. So that you do the frequency, and the frequency, or Wait. Calculate the period and the frequency. Did I do the frequency? I didn't do the frequency, my bad. So the frequency is simple. Frequency C is 1 over the period. So 1 over 30 milliseconds. Or 30 milliseconds is 30 times 10 to the negative 3. What's the frequency earlier? How many times will this be going? 30, not 33 seconds. 33.3 recurrent hertz, right? Or 33.3 to the nearest to 1 decimal place. Hertz, right? Hertz. Lovely. Calculate the maximum power dissipated in the resistor. So how do you find the maximum power? Using that peak-to-peak voltage. And if I do this question on my channel before. So power is equal to I squared R. You could use that. P is equal to I squared R. Or you could use P is equal to IV. In this case, you're not going to use that peak to peak. You have to use that 180, you know. 180 times 4. You can't use the peak to peak. This going up to create 4 amps and then coming down to 0 and then creating 4 amps the next way. This in doing what you think you're doing there. You have to use that 180. That, you can't use the peak to peak for that. Okay, so calculate the maximum power. It's going to be equal to IV. P is equal to IV. So I is 4 amps. And we got V in terms of voltage times 180. How much this is going to be? 720. And this is solid watts. Why isn't it chat if you understand that, if you agree? I squared R will work as well. Besties, what are you talking about? You can use this as well. You'll get the same thing. I squared is what? 16 times R, 16 times is like a combined the two equation in one. 16 times 45. You get the same 720. So Samantha's asking, yeah, you can use the same thing as well in this case. P is equal to I squared R. Okay, fine. Let me move on. What next? I'm gonna scroll along and see if anybody's sending any other really interesting thing. Somebody sent another thing. I feel this is the last question here, boy. Pick and choose. It have a question on circuits. What is this? Is a paper 3 question? There's a paper 3 question. Somebody see this question and probably frightened because they didn't see no units now. What is space? What's this question? This looking like a paper 3 question. Like, don't worry, like they probably see this and like, so where the units, how to do this. That look like a paper 3 question. You're supposed to set up the apparatus, plug it in, and get your answers. What else you seeing, boy? I seeing a question on thermocouple and thing. Just notes. Thermocouple laboratory thermometer, Charles law, just notes. In a sealed cylinder, what is the percentage increase of in volume of the gas? So just another gas law again. I think you should be able to do that. I'm looking for like a really tough question. Okay, here's a really tough looking moments question. Paper tree, nothing. No, I was just showing you all that there's a paper tree. No zoom in required. There we go. I kind of lock it on top of another paper. So security. How much time we could do question like this, boy? Or you could do this question. Why is in the chat if you could do this question? Do this one. Yeah, well, all my students are no excuse, and that is one of the negative things that come in my lessons. You kind of have no excuse. so if you know your slack off and study, you have everything in front of you, have everything. And they could go back and watch all my videos and things. Like all the classes we teach since last year, they can go back and watch it. We have it in a nice little website for them. Do it for the people. I do this in Form G. Why them just bring turning forces so why not seeing it clearly? If you're not seeing clearly, I mean it's not the best. But if you see what you're supposed to be seeing me in 1080p. So if I fuzzy and that fuzzy, something wrong with your thing, right? And you need to go and raise up your setting. Okay, so it's a wild question. It has one set of different things on this, but 0.3, that force there. This question real crazy. This question come in 2003. They don't bring it that. They don't bring it that crazy. They don't. I can tell you that they don't bring it this crazy again. Look at that. Look at that. Look at that. All of that. I see the normal reaction force. I don't really care to read none of them things. Write down the expression W, including WRC and FA for the total counterclockwise moments about pivot B. Pivot B. So I need to find everybody and kind of gauge them up here. Wow, what a question. What a question. So who doing things? He doing things. He doing things. He as well doing things. About pivot B. Oh, look, that is doing things as well. Why am I thinking we need zooming out for, boy? This as well as doing things. You can ignore this. This is a tricky thing. That's counterweight. This is the counterweight thing here. So look at all of these forces. Look at all of the, anybody from any other force here, boy? And what they wanted we? They wanted we to do WRC and FA. WRC and this is FA. About pivot B. So the total anti-clockwise. I hope I can see you are doing in the corner there. Yeah, I should be able to see. So so far, the total, good. Right bigger. Right in two lines. So the total anti-clockwise moments must be equal to the total clockwise moments. So this is about point B. So this force, we can start to determine who doing clockwise, or which one first, anti-clockwise? And anti-clockwise is only this. Anti-clockwise is only that. Hold on, All right, reaction force, F is the force applied, blah, 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 blah. The only one doing a clockwise is that. Anybody else seen any other clockwise force? Any other force that creating a clockwise thing? Somebody saying the pivot is B, so you don't need the 600. Nah, that's false. That's falseness. That's falsehood. You need this. If it's a force directly on the pivot, then you can ignore it. So only 600. So the only anti-clockwise is 600 times that distance, and that distance is half of 6, I'm guessing. Yes, so 3, right? Because it's 3 this way, so it's all right. So 600 times 3. So you get to relax on that side there by yourself. As a matter of fact, I feel like that equal sign need to come because they're going on a real action taking place here. So you put you over there, but up, and all the rest is anti-clockwise action. So let me go. How far away is FA? 0.3 and 0.8 add up. So FA times 1.1. Why isn't each other follow with me, right? And a moment is always a force, always a product of the force and the perpendicular distance. W times 0.8 and 30 newtons. Have a little 30 newtons action taking place there earlier. 30 newtons times, that was really unnecessary though. What is that 30 newtons about? That part was real unnecessary. You could just leave out that 30 newtons and ease you up times 0.25. Anybody have any quarrels there? Plus, what is it? RC times the whole thing, 6. So we got to go there. Good to go. And that's what I wanted. There you go. No, there's a sheet with constants and that kind of thing that they give you in physics. The total clockwise moment about pivot B. Oh, no, I made a mistake. The total counterclockwise moment. So I went and do my own thing. Then just what the total. Write down expressions including WRC and for this and that. The total counterclockwise moments, well, this is sus. The total counterclockwise moments is just this first part, 600 times 3. And I really feel into right over the second part, the clockwise moments is this second part that I have over here, up top. And if I can hit my little copies, boy. Let me try a thing. Copy. Wait a space. Peace. Next, I will get a little faster. But that's it. Do I put it in the right way, right? This is, oh my gosh. This is clockwise. We go fix that. We will fix that. Why not going to select by? We are fixing that, people. 600 is equal to that. And did I do it here too? Okay, I did it here as well. I need to do a swappy daps here, boy. How are we doing that? Ding, 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 ding. Why isn't each other if you all understand this though? Albeit I made a mistake. Yeah. All I had to do was move the labels. Yeah, no, it's really easy to do, move the labels and things, but I need to learn how to lasso this stuff real quick. Okay, so that's the total anti-clockwise, total clockwise. What is the value of RC when the boom first loses? Where this line come out from? When the boom first loses contact with its cradle? 0. That's the end of this question. What do you rest of this question? This question going in and do some real nice things with the rest of that question. No. Right, here it is. I know that question. I'm more suited. All right. Peace. So we already figured out, let's send me these things real while away. What is the value of RC when the boom first loses contact with its cradle? Well, RC gotta be 0. I want to lock him down. I'll block out some of my working, of course. The frustration is building up. Ding, 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 ding. Okay, so what is the value of RC when the boom first loses contact? 0, right? You know that had to be 0. If this lose contact, if RC lost contact, it just losing contact. It means it didn't pushing up again. It just lose contact. RC is 0. RC is 0 when it just loses contact, people. That's just, you need to state that. So that's 0. Using the results of C2 above to find the mass of the counterweight that must be used if FA is 25 newtons is just enough to start raising the boom. So in other words, RC is this. FA, they tell you that there is 25 newtons and they want you to find the mass of the counterweight, which is W. And we're trying to figure out W. 25 newtons. Anything here given in kilograms? Let me just double check and make sure they're setting me up. Ching, 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 ching. So you're trying to do the paper for me, or? No. Using the results of blah, 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 FA. That is it. Well, that's bun and cheese. We don't have that to go. That's to go. I ever play all fours before, that's to go, because they're plugging in FA, they're plugging in RC for us. So I could just take back this initial part up here. That's to go. And we can go down here and paste him. Where's paste again? Badang. And we can move him up a little bit too. Okay, Italia. Move him up there. And now, well, this back to front. Well, okay, I'd sort it back out. So FA is, what is it FA was? I think it's time to wrap up, people. Brain drain. Yeah, I gotta wrap up. So all you need to do is go and check on the physics channel as soon as I'm done, right? FA is 25. 25 times 1.1. That's what feet saying. Plus W was what we're trying to find. And 30 newtons. This was just outer wildness. Whoever made the question, just train this one outer wildness. I really don't need that ND. I just what the magnitude. RC is 0 now. Is equal to 600 times 3. 0 times 6 is still 0. So let me get all these numbers to number it for you. 25.11. No, 25 times 1.1. Yeah, boy, like I shut it down too. Plus 30 times 0.25. A quarter of 30. 30 times, if I see why I type in my calculator here, 0.25 plus 25 times 1.1.
I'm missing out. I'm doing all kind of thing. So this is 35 plus 0.8 W is equal to 1800. So this is 0. All you get this? Why isn't it chat if all you get this? 1800 minus 35, 1765. Now we see if this making sense. Divided by 0.8, 2206.25 newtons. Did they ask for newtons or mass? They see the actual mass. They're trying to take we little scrunting marks from me just so. So the actual mass. So we need to come back here and sort of that. So if that's in newtons, therefore the mass of counterweight is equal to 2206.25 divided by 10. Because it's in newtons now, we need to bring him down to size. kg. All right, read out that 10. How much I'll understand this. Use results. So I have lots of videos, and not lots, but some nice clinical videos for you all to watch on this channel where I go through like entire physics past papers. I have maybe at least 3. Then I have different topics in physics as well. Probably you all didn't know. How many of you all know I had the entire organic chemistry on this channel? Like in nice, succinct, nice little short videos. You could go and watch them videos there. But chem done, so no, don't go and watch them videos. So you can watch the videos where I do the past papers. You can go and check out Samantha Blundell channel, and love and blessings to you. If you want to keep lessons with us, all our Unit 2 classes starting in August, but the Unit 1 starting in September. So if you know you're going to do keep and you want to have the best online lessons in the entire Caribbean, sign up today, right? Well, soon. Sign up today. Plus 1868 is the Trinidad area code. Then it's 4724221. So I watched that came before. That organics playlist really sweet. Yeah. We watched the organic. Nice. Some funny videos now. Organic was so easy. I expected stuff on polymers. CXC physics going and come easy. I can tell you that from now. If you, for anybody who studies CXC physics, it's going and come real easy. Mark my words, right? This is the student hub. We have classes in CAPE, classes in CSEC, everything you want. It's the best. It's the best. No cap. Best. All right, so online lessons here. Well, as I can tell you, boy. And like by next year, we'll have real resources. So we'll have more resources in different subjects like formulas, sheet, and the thing that you right now you wish you had for physics, that like yes, you are ready formulas and definitions and things. All of that we have in that. We stating things out here. Love and blessings, people. Press like as you go. If you didn't press like yet. No. Seriously, if you didn't press like, take your time, close the chat, and press like on the video. It's help. That's why it's pay for your lessons here. You press like. Why isn't the chat if you press like already? I say press like. All the YouTubers, they say, don't forget to like and subscribe. And nobody is like and nobody is subscribed. Press like and subscribe. It will help people in the future. And you tell me what the numbers looking like on the like date. Going up? I can't see it right now. We likes going up. So how much if I seen any student a pure maths class or pure maths class is going to be taught? Well, I'm like the head maths teacher in the student hub, so I'm going to be a key part of it, but the lessons are going to be brought to you by Miss Nalini Prasad. If you're in the student hub, you know Miss Nalini Prasad. She's a boss, a nice, very gentle, calm person, but she's a maths whiz. You could that's pure maths unit 1, and pure maths unit 2 is taught by Darian Giuseppe. He also has a YouTube channel with 1-star pure maths in it. 589, 463, 500. Right, so the likes gone up. Love and blessings. Love and blessings. Don't want to keep you all anymore. You all have specific stuff that you all need to study for yourself. Later. Man, see, subscribe with 3 accounts. Well done. Subscribe.